Today we're back taking another look at the Discovery Sky bed distance sensor, only today's all about Marlin firmware. What's up everyone, Chris here. A couple of weeks ago we did a video on the Discovery Sky bed distance sensor, but that video was focused on Clipper firmware. Now if you run Marlin firmware, this is the video for you. And this particular sensor actually has a few more tricks that it can do in Marlin than it can in Clipper. So it's definitely worth our time to walk through configuring it. Now that's what we're going to do today, but I am assuming that you already have a Marlin configuration that works, and we're just going to add the functionality for this bed distance sensor. I will go into auto bed leveling a bit just so we can get everything up and working. Now, it's not super straightforward to get all this set up, but hopefully by the end of this video, you'll be able to get it set up in Marlin and use the sensor if you wish. Again, it does do things a bit differently. It does allow you to do a lot of things like bed leveling much quicker than some other sensors might. So, let's get into it. So basically, this is what you're going to get if you buy one of these BD probes. You have the probe here, it's an inductive style, it's been shielded, and then you have the controller on the other end. Now the controller works a little bit differently. You'll see that in the configuration. But we have 5 pins on here, and it does accept a plug the same as a BL Touch would. In fact, they give you that wiring harness. So you have the smaller JST style connector, like on a BL Touch, coming out to some DuPont connectors. So this comes with the probe. And just to take that one step further, if you do have a BL Touch, you can swap in the BD probe directly on that wiring harness. You don't have to swap out anything. Definitely confirm how it's plugged into your board to make sure you have the right pin out, but it's the same plug. And here on our Ender 3, this is a BL Touch mount. In fact, this one came from Creality, but it's just a little metal bracket that was intended to use these dog ears that come on your BL Touch. It just hangs right there. And the printed parts that they give you on their site do the same offset as a BL Touch would. So you can use the hardware for your BL Touch to mount this whole thing up. They give you 3 different lengths of mount depending on the hot-end carriage that you have. This is the longest one that I have on here today. The probe does need to be relatively close to the same height as the nozzle. You'll see that as we configure it. But the probe just snaps in the end of these printed parts. You'll want the smooth side facing down towards the bed. You can see it's been sealed here on the back. But that just pushes into the printed part, and then you can set it with a screw here if you'd like. Just thread it into the plastic. And then the module that it comes with that hooks to the sensor, you can just work that into your wire loom. I would suggest leaving it somewhat exposed so you can see that LED. The LED is going to give you an indication of what the probe is doing. On the board side, today in our Ender 3, we have our Big Tree Tech Mini version 3. I'm just using the probe pins. But you can use any 5-volt and ground pin you wish on your board, and then any 2 GPIO pins. On that sensor there are 2 grounds, but with the probe pin, you have pins that simulate the Z-Min end stop, as well as the servo pin, so that you can use something like a BL Touch. But you can use those same pins on this probe. They have a GitHub page with all the information you need on the sensor and how to get it set up, but just to talk about the wiring a little bit more, you can see the BL Touch, they've given you an example of how that loom pins out, and here's the sensor. You do have an SDA and a clock pin. But again, those can use any GPIO pin you'd like to configure. Today we have our Z-Min pin on the SDA, and then the servo pin on our clock pin. Again, we're using that Big Tree Tech board. If you take a look at our Z probe pins right here, we're using that PC14 and PA1. So just to give you an idea side by side, we have that PC14 for our SDA pin, that would be Z-Min, and then the PA1 for our clock pin, our servo pin. So that's how I have it wired up. You'll see more of these pin numbers in the configuration. So getting the hardware portion for this sensor set up is very straightforward. It's kind of meant to take the place of a BL Touch. It even uses the same plug. You could use the same harness if you have one of those on your printer today. You just have to pick some pins on the main board you want to use and then get it set up in the firmware. We're going to talk all about that. But having said that, if you have a BL Touch, this sensor really only works with steel sheets. I've even tried it on the thin aluminum beds. It doesn't seem to sense that aluminum well enough to trigger as it should. You have to use that steel plate. Today we're using one that has the PEI sticker on it, the thin sheet. It does work pretty well, but just keep that in mind. If you're not using one of those steel sheets, this probably isn't going to work that well for you. But nowadays a lot of us are. So let's continue on and get into the firmware. So here we are in Visual Studio Code in the Marlin Configuration.h file. So there's quite a few things we need to change to get this sensor set up. The good news is BD sensor is supported directly. There's a couple of features that aren't quite yet, but they will be soon. We'll talk more about that in a moment. But the first thing we're going to do is just search for BD sensor. So here it is. We'll just take a comment off of that line, letting it know that's the sensor we want to use. And we also want to enable Z-safe homing so that it homes in the center of the bed to prevent crashes. So we can just search for safe_home. There's Z-safe homing, and we'll take the line off of that one to uncomment it. By default, it should be able to home in the center of the bed. It just divides the bed in half so that it gets to the center in Marlin. That's just how it works. Remember, I am using a configuration that already works for my Ender 3 on my Big Tree Tech Mini version 3 board. If you need that configuration, the default one, it's out there in the configuration examples. You can just grab it and load it in and compile. The next thing we need to look at is the Z-min probe uses Z-min in-stop pin. You saw before we're using the probe pins on the mini board and not the Z-min. They act the same, but you need to make sure this is configured correctly to use this BD sensor, as it's not the same as other probes. So the min in-stop pin defined, we need to comment that out. We're not going to be able to use that. And we also need to force it so it always uses the probe for Z homing. That's this line right here. That'll just make sure that it's always going to home with that probe. Now, we currently don't have pins for the probe to use. You might notice that. Sometimes we would use this line here. We're actually going to use I2C pins. We have to configure those in the pins file. You'll see that more in a moment. We're jumping around just a little bit. I just want to give you the order of things that you need to configure. Next thing we need to be worried about is the probe feed rate that it uses. We need to slow down just a little bit for this probe. So what we're looking for, let's Control F again, Z_probe _ feed rate. The slow line right here is what we're looking for. It's just half of the fast feed rate by default. We want to divide that by 16, so it slows it way down. So just overtype that 2 with a 16. So we're good there in configuration.h. Now we need to move to configuration_adv.h. We want to enable baby stepping, so we'll just do Control F to find baby stepping. We'll take the comment off of that line. This allows the probe to be able to adjust it as it sees fit. You don't want to enable the probe offset because you don't want an offset with this probe. You just want the probe to be able to adjust it here and there. So baby stepping will allow that. So we're good there. And we also want to edit home bump divisor. You might have seen this before if you've used sensorless homing in Marlin, but we'll just search bump. So you want this line right here. And for Z, by default, it's usually 4. We're going to make it 8. Basically, that's half of the new homing feed rate that we used. Now we need to configure some pins for this probe to use. Basically, we're just going to reuse the pins that I showed you before, but we're going to create a couple of line items, so we define it as an I2C pin for SDA and SCL. In Marlin, you need to do that in your pins file. So to find your pins file, come over here to source. There's going to be pins, and it's listed by processor on your board. The Big Tree Tech Mini version 3 has an STM32 chip, but it's a G0 chip. So we'll expand this and then scroll down, and there should be your mini board right here. And it has some settings for I2C and all that right now, but I'm just going to scroll down a bit and we're going to enter some new settings. So I'm just going to put them here at the bottom. All of these are on the GitHub, so you can just copy and paste them from there. But I'm going to copy in what they have listed, and then we'll make some edits. So these are the lines you need. We have to define our I2C bed distance SDA pin, our SCL pin, and then the delay. And that's the delay on the frequency where it triggers. But as you saw before from a schematic, we're using that probe pin, those 5 pins where we have Z-min and then the servo pin like there would be on a BL Touch. Back to our pinout for our board, we have that PC14 and the PA1. So our SDA pin was PC14, and then our SCL pin was PA1. So that's how it knows how to talk to the sensor, so it goes to the right pins so we can get it triggered. We didn't define any pins before. This is going to take care of that. So we're good here. One last thing we need to deal with is how it auto bed levels. Now it's going to be able to do its own thing. If you saw the first video, it does a leveling sequence, it can scan the bed, all of that good stuff. But if you'd like to use your G29 command, like you normally do with a bed level, especially before every print, we need to configure that. So let's just search bilinear, and that's going to get us to the bed leveling section, and we're just going to take the comment off of auto bed leveling bilinear. That's what you're usually used to seeing when you do auto level. And because this probe is just a little bit different, we need to set the clearances. So just search for clearance. And since there's nothing to deploy, on Z clearance deploy probe, we're going to set that to 0. Between probes, we're just going to set it to 1. And then multi-probe 1. Because you don't have to have a lot of travel in between spots to probe. That's kind of the whole point. But with that change, we should be good. We should be ready to go ahead and compile and get our file over to the printer so we can flash it. I just like to use the Marlin Auto Build tool. Here's the build tool. It knows what board we have just based on the configuration files, and you can just hit build. Once the compile is complete, it should open the firmware.bin file in the folder where it was going to save it. So we can copy that over to our SD card. This printer does currently have Clipper on it. I'm just going to delete this current file. And it works the same way for this board with Marlin and Clipper. We're just going to put the SD card in and power it up. Now you will notice if everything went correctly, the system came up on Marlin, the correct version, that you'll have BD here and its current height. So it's always measuring, but it's sending an M117 so you can see it on the screen. Now we need to calibrate it. With Marlin, we have to do it a little different way. They give us a tool to be able to do that. To start, we need to just take our Z-axis and put the nozzle down on the bed so it just touches. With the BD sensor, you don't have to worry about Z offset. It takes care of that because it assumes that 0 is with the nozzle on the bed, and you've used the correct height part here for it to measure it correctly. And then we go through the calibrate. So it knows if the nozzle is on the bed, that's 0, then it will calculate the offset for you. So when you have the nozzle on the bed where you want it, I suggest you do it in the center. Go ahead and power the printer off. And then we can power it back on. And we're going to cable up USB to our computer so we can run that calibrate. This just makes sure that everything is cleared out, so it knows that it's going to get a good calibration. So back to the GitHub for the BD sensor. They show you what to do, what commands to run, and then they give you this configuration tool. So we'll go ahead and download that. Basically, it's just another terminal that will graph the data for you. It's just helpful, more helpful than something like Prawnterface might be. Once that download's complete, we'll just open it up after we've extracted it, and we'll run it. Windows complains, but we're going to run anyway. And here's our tool. It should know what COM port your printer's plugged in on. We're on 12. It's going to guess at the baud rate. Use whatever you configured in Marlin and just hit open port. Now it really doesn't give you any indication that it's connected, but run this button down here just to get the version. This will test the sensor. If it comes back with the version, PandaPie3D.com, then you know we're communicating with the printer and the sensor is communicating with the board. So we're in pretty good shape so far. Now we want to calibrate. So calibrate is going to start moving the nozzle up 1/10 of a millimeter at a time, so it gets a good scope of how sensitive that sensor is. And this is the command over here, M102S-6, and it's just going to start moving that print head up. So we'll start that running. You can see while the calibrate's running, it's moving up in Z. It'll go all the way to 4 millimeter. Sensor has been calibrated. You can see it in the terminal right here. And then you can read that calibration data back. That's the M102S-5. We'll just hit this button. And it plots out a graph for you. This just gives you an idea of how sensitive that sensor is at the distance. What you're looking for is you want that first point to be around 100. That's how you know you have the height set correctly for the sensor and you're using a proper bed surface. When I was testing aluminum beds before, I couldn't get anywhere close to that 100. It was much higher. So the higher the number, the further away you are from the bed, or the less the sensor's able to sense the material. And as long as this first point down here isn't greater than 400, then you should have a pretty good set of values you can use. And you're done calibrating the sensor. It's good from here on out. Then you can utilize it how you want to, whether you do the traditional level or you use some of these cool features that this sensor brings. So now I'm going to open up Pronterface just because I'm a little bit more familiar with it, but it will allow us to calculate the bed mesh. So you can see the mesh laid out and then we can put it into a tool so it looks a little bit more obvious than the BD tool. They probably both work the same, but I'm more familiar with this one. So I'm just going to connect up after I've disconnected that previous tool. They can't both connect at the same time. The first thing that I want to do is check and make sure the end stop is functioning as it should. We don't want any crashing. So I'm just going to set motors off and I'm going to return the Z back down to the bed. You can see the light on the sensor. As you move up and down, it's going to turn on and off. You can see that LED right there. We're at the bed. That means the sensor has been triggered. And you can see as we move back, it goes out. So just verify that first. It is triggering. Then back to Pronterface. We want to run an M119 to check in-stop status. We want to make sure that Z-min and probe is triggered. So that's good. It should stop the nozzle from crashing into the bed. Now, let's bring it up a bit until we see our LED go out. It is currently out. Back to Pronterface, M119. You'll notice Z-min is triggered. We're not actually using that as our trigger for a minimum in-stop. We're using the probe, and it is now open. So we should be good. If I go ahead and hit Home All, X and Y are in good shape. We have Z safe homing. Z has homed correctly. It is stopping the Z axis. That's what we want to see. So we know the probe is good, and I have noticed that it's not directly in the center of the bed when it homes Z, and that's because we probably didn't set X and Y offset. So let's jump back to the config real quick. Back to configuration.h, I'm just going to do a find on offset. And the default values are 10, 10, and 0. Now, this is the bug fix version. I've showed you two versions in this video. The standard branch had the offsets a little differently. This is the bug fix one, the latest and greatest. And by the time you watch this video, it's probably not going to matter. The standard branch will probably support all the features I want to show you. The 2.1.21, I believe, is what I was showing you before. It does support BD sensor, but not all of its features. The newer versions, it supports all of them. So that's what we're looking at right now. But nevertheless, I want to make sure that the offset is set correctly. And you can just judge that with a ruler. So from the nozzle to the center of that probe, we're just going to get our ruler out. And we're setting somewhere around 47 millimeters. And then measure if it's in the front or the back of the probe, depending on your mount. Mine is setting about 7 millimeters, the probe in front of the nozzle. So we'll just make that adjustment real quick. Marlin gives you a good idea of what front, back, left, right values are going to be. If you're over to the left, you can see it right here, you're going to be negative. So negative 47 to the left. And if the probe is in front, that is also negative, and ours is, so -7. You never, again, have to set that Z offset. The probe knows all of that. But I want it to be a little closer in the bed, so we're going to go with these values. I'll just go ahead and re-upload it. You can set these in EEPROM as well, but I just want to save them, and then we'll continue on with the video. So the offset changes have been flashed. Remember, with certain things, if you're using EEPROM, you need to reset those. Offset is one of those, as I mentioned before. Just run an M502 to bring in the defaults. That's the firmware that you brought in, and the M500 to write that to EEPROM. That'll make sure those offsets and other changes are updated. That's always good to run, especially if you're seeing an issue you didn't expect. Now, with our printer here, we're just going to go ahead and hit home to G28 and get us back to the center where we should be. And with the settings that we've made, you can go ahead and level like you normally would. You can run a G29 before each print and create a mesh. So let's just do that real quick. All I'm going to run here on the command line is a G29. However many spots we have it set in the firmware, this probe is going to run around to all those spots and take a measurement, just like any other probe would, only it doesn't have to stop and go up and down in Z. It can just run over and scan it quickly. And here's our mesh in Pronterface. You can go to a couple of different websites and visualize this, or if you have Octoprint, even better. But we'll just paste our data in here and hit visualize. And here's our bed surface. Not bad. Again, this is a standard G29. That sensor will do that. Now, the next thing this sensor will do. So we have our BD sensor defined. The BD sensor will do a no stop level, where it doesn't have to stop at each point. It just runs a whole scan of the bed. And in the newer versions of Marlin, like this one here with bug fix, you can enable that. All you have to do is enter a define, and the statement that you need is over here on the GitHub. It's just BD sensor probe no stop. So we'll copy that, and we'll paste in our configuration. That will enable this feature, and that will be the default. So you can go ahead and compile and load it to the printer one more time. So with that no stop feature in place, we've homed. Let's go ahead and run that G29 again. Now we're just running a really quick scan of the bed. It will go forward and then backward just to verify. This is even a quicker way to use the sensor to do the auto bed leveling. And we'll just take that grid as well. It looks to be pretty close to the same thing, but let's go ahead and take a look at it. Here they are side by side. Here's the one with the stops. Here's the one with no stop. They're pretty much exactly the same. So whichever one you'd like to use, they're both pretty accurate. No problems at all. The no stop is a great feature if you want to do that G29. So this bed distance sensor, you can use it just like any other probe. You can do your G29, you can even do that no stop leveling, and it seems to be very accurate no matter which mode you use it in. But with Marlin firmware, it supports a few other features. One being you can use it as a dial indicator. So you can get your bed roughed in if you have bed knobs before you even start that leveling process. As I showed you before, the sensor down here is constantly monitoring. So it's always checking that bed. And you can just use these numbers to kind of dial each bed knob in. So to show you what I mean, I'm just going to home the printer one more time. After it's home, you can do an M114. You can see Z right now is at about 1/2 millimeter. Let's go ahead and tell it to bring Z up another millimeter, so we'll be 1.5 millimeters. We'll just hit the button over here. So 1.5, that's good. I just want it to be away from the bed a bit before we do this. And I want to leave that Z motor engaged so it doesn't go up and down on accident. I'm going to do an M84XY. That disengages the X and Y motor, but we'll leave Z intact. Now we can go back to the printer, and I'm just going to put the sensor over the top of the screw where the bed knob would be, just in general. You can see we're at a 134 right now. Remember, that's active, so as we start moving this, it's going to change. So now I'm at a 140. And I'm just going to start at that point. I'm going to use this one as the source of truth. It might not be, but after we're done, we can adjust all of them. You'll have to go around a couple of times. But we're going to use this as a dial indicator to tell how far away the bed is, and we can adjust it with the knobs. So we're over that knob. let's move to over this knob. We're at a 101, so we're going to bring that one up to 140. To make the number go higher, it's actually getting the bed further from the sensor. So we're bringing the surface down a bit to 140. Then we'll move to the back knob. We're at 90. Now we're at 139, 140. Just get it close. And then the other back knob. 104, 140. And then move around a couple of times and make sure they're all even. It doesn't have to be at that first number, just make sure they're equal. You want the tension of that spring to be somewhat similar all the way around, but your sensor should be able to tell you that. And you're going to have that teeter-totter effect. If you change one, it's going to change the opposite wheel. So we're pretty good all the way around. Let's do another G29 just to see the difference. Here's our bed mesh now that we did the dial indicator feature here. We'll just copy that. And it looks much more even overall. You can see it's still a little bit higher over on this side. If you wanted to keep going around, I'm sure you could get it more accurate. We're at a 0.36 over here, 0.6 over there. So 300 micron difference. But it's another feature this sensor has. So you're starting to see the constant feedback that this sensor is able to provide could be very useful in a couple of different situations. But there's one more trick I want to show you. It is compensating for the bed level all the time. You don't have to run that G29. You don't have to make the mesh. It's constantly making adjustments if you turn that on. So let me show you how to do that. Even if you were to skew the bed sheet a bit, it should be able to compensate for it. Now, it's not going to work miracles, but not having to do that mesh or build it, just having it monitor most of the time, is pretty convenient. So here we are in Prusa Slicer in our start G code. If you would like to have that sensor monitor the bed all the time and start making adjustments, we need to turn it on with an M102 command. Just do that right after your G28. Normally G28 will kick leveling off, or it will make your mesh go back to 0. We don't really need to worry about that. We just need to turn that auto compensation on. And you need to tell it with an S how many layers you would like it to be on for. And it's by micron. So 0.4, if we just did a 4 here, that would be 400 micron. We're printing at a 0.2 layer height, so it's going to compensate for the first 2 layers. You don't want it to compensate for the whole model, because the sensor can't sense the bed all the way up. It's only good for about 4 millimeter. So we're just going to let it compensate for the first 2 layers. After that, we're going to say that everything is good. As it prints upwards, it'll be able to lay on top of those layers after it's made the compensation. Hopefully that makes sense. But we're going to let it adjust for 2 layers. Then we'll slice our test model, and we'll go to the print. So you can see the print has started. It's starting to lay down that first layer. You can also see that I have some scars on my bed plate. It took a little bit of dialing this in, a little trial and error to get it to work. I did have a few mistakes, as it were. But you can see it's laying down the first layer. We've got it configured correctly. And your number over here is adjusting. So it's compensating for that first layer on the fly. Now, it's not a large amount, but it's enough to get you a really nice flat layer. We'll let it do a couple of more lines here. And again, this isn't going to work magic, but it can make a fairly drastic compensation based on what we're dealing with here. Remember, this layer height is only 200 micron. And while it's printing, I just want to show you if you do an M420, you can get the status on the leveling. Leveling is off. That means the bed mesh that you created is not in effect. The sensor is doing it on the fly. And if you'd like to verify that, you can always just reach over and put a finger on the lead screw. It uses baby stepping to adjust it. It's already built into the firmware, but you can feel it adjusting just very small amounts, just a few steps here and there. So the first layer is looking really good. I hate to disturb it, but I'm going to grab just a very small drill bit here, and I'm going to place it under the corner of our sheet, just so it skews the sheet a little bit as it gets closer to this corner of the print. You can see the layer has already gotten fatter. The sensor has tried to push the nozzle away from the bed. This is a really drastic change with that drill bit, but it should be able to compensate for it. It'll figure it out and try to level that first layer out. As it continues to print, I moved around the drill bit just a bit just to see what it would do. You can see it's doing its best. It's trying to compensate. It's not quite making it to the edge of the print where it should, but it did keep the nozzle from gouging a hole in the plate. It's lifting it up as it sees it rise on the bed here, as it goes closer to that drill bit. Now I'm really curious if it will go back to normal, like this area here, if I pull the drill bit out. So let's check it. This is a 2mm drill bit, by the way, so that's quite a bit at a 0.2 layer height to have to compensate for. And it does look like it's creating much smoother layers now that the drill bit's gone. So kind of a cool feature, maybe not the best use case, but you can see how you don't even have to run a mesh, you can just let it do the work for you. So there we go, the Discovery Sky bed distance sensor installed on a 3D printer running Marlin. And as you've seen with the Marlin firmware, it has a few extra things that it can do, like that active bed leveling. You don't even have to create a mesh, and you can kind of use it for a dial indicator to help get your bed as level as possible. Now remember, with this sensor, it works best with a steel sheet. I had a hard time getting it working even on aluminum. So keep that in mind, you're going to have one of those to get this sensor to work correctly. Also, there is the price point of $35. You can get some of these inductive sensors very cheaply, but not one that has as granular feedback as this one. So depending on your printer configuration, you don't want to make those meshes anymore, or the firmware you're running, this might be the sensor for you. So hopefully you found this helpful. That is it for today, and I'll see you really soon on the next one.